Intermittent fasting has become a buzzword in the realms of health and wellness, attracting attention from researchers, medical professionals, and everyday individuals alike. But what is it about this ancient practice, now repackaged for modern lifestyles, that so powerfully influences our bodies and may even help us live longer, healthier lives? The science behind intermittent fasting is both fascinating and complex, drawing from evolutionary biology, cellular metabolism, and cutting-edge clinical research. To truly understand how intermittent fasting intersects with longevity, we must delve into its mechanisms, its effects on the human body, and the evolving evidence that supports its remarkable benefits. Intermittent fasting, at its core, is an eating pattern that cycles between periods of eating and periods of fasting. Unlike traditional diets that dictate what you eat, intermittent fasting is primarily concerned with when you eat. There are several popular approaches. The 16-8 method, where individuals fast for 16 hours and consume all their meals within an 8-hour window. Alternate day fasting, which involves fasting every other day. And the 5.2 method, where people eat normally 5 days a week and restrict calories significantly for 2 non-consecutive days. While these protocols vary in their specifics, the underlying principle remains the same: periodic abstinence from food. To appreciate why intermittent fasting may promote longevity, it helps to look back through the lens of evolution. For most of human history, food was not always readily available. Our ancestors often endured periods of scarcity, and our bodies adapted to these conditions. This means our physiology is well equipped to handle intermittent periods without food. In fact, some scientists argue that regular fasting may trigger beneficial stress responses that help repair and rejuvenate our cells, ultimately extending lifespan. At the heart of intermittent fasting's impact on longevity is its effect on cellular processes. When we eat, our bodies break down food into glucose, which is then used for energy. Insulin, a hormone produced by the pancreas, helps shuttle glucose from the bloodstream into cells. Frequent eating keeps insulin levels elevated, which can contribute to insulin resistance over time, a precursor to metabolic diseases like type 2 diabetes. By allowing the body to rest from constant food intake, intermittent fasting lowers insulin levels and improves insulin sensitivity. This alone can have profound long-term health benefits. But the story goes deeper. During fasting periods, the body shifts from relying on glucose to burning fat for fuel, a state known as ketosis. This metabolic switch not only helps with weight management, but also triggers a process called autophagy. Autophagy, meaning self-eating, is the body's way of cleaning out damaged cells and recycling their components. This process is crucial for cellular maintenance and has been linked to protection against neurodegenerative diseases, cancer, and inflammation. By promoting autophagy, intermittent fasting helps our cells stay young and functional. Research in animals provides some of the most compelling evidence for intermittent fasting's role in longevity. Studies in mice have shown that calorie restriction and various forms of intermittent fasting can extend lifespan, reduce the incidence of age-related diseases, and improve cognitive function. In one landmark study, mice that were allowed to eat only during a restricted window lived longer and had healthier metabolisms compared to those with constant access to food. While translating these findings directly to humans is complex, the underlying mechanisms, reduced inflammation, improved metabolic health, and enhanced cellular repair, appear relevant across species. Human studies, though more limited in duration and scope, are beginning to paint a promising picture. Clinical trials have demonstrated that intermittent fasting can improve markers of cardiovascular health, lower blood pressure, reduce cholesterol levels, and decrease inflammation. These are all factors known to contribute to aging and age-related diseases. Moreover, intermittent fasting has been shown to help regulate blood sugar levels, reduce body fat, and preserve lean muscle mass, which are crucial for maintaining vitality as we age. One of the most intriguing areas of research involves the role of intermittent fasting in protecting the brain. Aging is often accompanied by cognitive decline, memory loss, and an increased risk of neurodegenerative disorders such as Alzheimer's and Parkinson's disease. Animal studies suggest that fasting may enhance brain health by promoting the growth of new neurons, reducing oxidative stress, and increasing the production of brain-derived neurotrophic factor, BDNF, a protein vital for learning and memory. While more research is needed in humans, preliminary evidence hints that intermittent fasting could help preserve cognitive function and delay the onset of neurological diseases. Intermittent fasting also affects hormones that regulate aging and longevity. For instance, fasting increases the secretion of human growth hormone, HGH, which plays a key role in tissue repair, muscle growth, and metabolism. Elevated HGH levels during fasting periods may help counteract the natural decline associated with aging. Additionally, intermittent fasting has been shown to reduce levels of insulin-like growth factor 1, IGF-1, a hormone linked to accelerated aging and increased cancer risk when present in excess. By modulating these hormones, intermittent fasting can create an internal environment conducive to longevity. Another critical aspect of intermittent fasting is its impact on inflammation, a silent contributor to aging and chronic disease. Chronic low-grade inflammation damages tissues, accelerates the aging process, and underlies many diseases of old age. Studies indicate that intermittent fasting can lower inflammatory markers in the body, help combat oxidative stress, and promote the production of anti-inflammatory compounds. This reduction in inflammation is thought to be a key reason why fasting is associated with better health and longer life. Weight management is yet another avenue through which intermittent fasting supports longevity. Obesity is a well-established risk factor for numerous age-related diseases, including cardiovascular disease, diabetes, and certain cancers. By making it easier to reduce caloric intake and burn fat, intermittent fasting helps prevent obesity and its associated complications. Furthermore, fasting may help maintain muscle mass and metabolic rate, reducing the risk of frailty and weakness in older age. Social and psychological factors also play a role in the benefits of intermittent fasting. Unlike restrictive diets that can feel punishing or lead to disordered eating, intermittent fasting is often perceived as more flexible and sustainable. By focusing on meal timing rather than calorie counting, individuals may experience less stress around food and greater adherence over time. This psychological ease can translate into better long-term outcomes and greater overall well-being. Despite its many potential benefits, intermittent fasting is not a panacea. It is important to consider individual differences, health conditions, and lifestyle factors before embarking on a fasting regimen. For example, people with certain medical conditions, pregnant or breastfeeding women, and those with a history of eating disorders should consult with healthcare professionals before attempting intermittent fasting. Moreover, the quality of food consumed during eating windows remains crucial. Nutrient-dense, whole foods should be prioritized to maximize health and longevity. As science continues to unravel the complexities of aging, intermittent fasting stands out as a promising intervention with the potential to enhance both lifespan and health span, the period of life spent in good health. While more long-term studies in humans are needed to confirm its effects on aging and longevity, the existing evidence is compelling. Fasting not only taps into our evolutionary heritage, but also engages powerful molecular and cellular pathways that protect against disease, support metabolic health, and promote cellular rejuvenation. Looking forward, researchers are exploring new frontiers in intermittent fasting, such as the timing of meals in relation to circadian rhythms, the impact of different fasting protocols, and the interplay between fasting and other lifestyle factors like exercise and sleep. Personalized approaches to fasting may eventually optimize its benefits for individuals based on genetics, age, and health status. In summary, intermittent fasting harnesses the body's natural ability to alternate between periods of feeding and fasting, a rhythm deeply rooted in our biology. By giving our cells time to repair, reducing inflammation, improving metabolic health, and supporting hormonal balance, fasting offers a powerful tool for those seeking to live longer, healthier lives. While it is not without its challenges, its simplicity and adaptability make it an attractive option for many. As our understanding of the science of intermittent fasting grows, it may well become a cornerstone of preventive medicine and healthy aging, helping us not only add years to our lives, but life to our years.